Hey, it's Random Code here, and today we're going to continue with the AdminF code exercises, and we're now hitting day 5. And day 5 are a bit different from the other ones because now we have some kind of input, and we then need to pass each of these inputs through some steps to create an output, and then we need to return the smallest output for each of these inputs. And when I read this the first time, it is a bit different, and as you can see here, the explanation is quite a bit longer than usual. The short explanation, hopefully it kind of makes sense, is that we have some kind of starting area, start a lower bound. And then so from 98 and 2 above, so 98 and 99, if any number is within this bound, change its value to its same different from the base value on this other base value. So for example, if we had the value, and if we have any values out of this bound, just return the same value. So this is an example from going from a seed to soil, for example. We can see that we have an input bound of 98, an area of 2, and an output bounds of 50, for example. So we have any number outside this bound, just return the same number. But when we hit 98, return 50. When we hit 99, return 51. But to then solve this, I have created actually a bit different. I'm using a bit more object-oriented programming concepts because I actually created a new class in Java called my step converter, where a step converter is going to be taking all the responsibility of like one step in this conversion. And it's then going to have a list of rules. So I'm going to have a list of these 3 numbers. And I will then simply check when I get my input, is my input within the range of my lower and upper bound for a given rule? And if it is, I then change my number to b, some quick calculations to find the actual value of my output. And I then simply use this step converter in my day 5 part 1, where I first kind of need to populate my step converter with data from all my steps. And I need to put all my seeds into my list of seeds, which are given in the beginning of our input, where we, for example, have seeds colon and all the seeds. So I do some basic splitting. First of all, I split my file on all the empty lines. So here it's going to be split here, here, and here. I then used my first line splitting on colon, removing empty space on left and right, splitting on empty space, find all my seeds, make them into longs and to list. And it's going to be shown shortly based on the input that actually Java integers are not large enough because the data numbers are going to be so insanely large. If we look at the actual input file here, we have millions and billions, but very, very large numbers, which then is going to cause problems if we just use integers. So actually I'm forced to use longs in this case. But it doesn't change much, but we're just using longs instead of integers simply because the numbers are too large. We then simply go through our input sections. So our sections of data, not looking at the first line, going from the index 1. And we then again separate them line by line. We do not look at the first line, and then we simply take each line, turn them into a list of integers, and pass them into our step converter. And then we have a step converter with its own rules for each section, these conversion area. This then very simply allow us a simple perform step where inside my step converter simply have this use rule method. We can then very simply say, okay, we have some kind of seed. We then for each step, so kind of for each area, perform this step, then take the output of this step, perform this step, take the output of this step, perform this step, and so on. And then in the end, we're going to end up having a result. Along, it's going to be returned, and we're going to add it to a list. And then in the end, we need to find the smallest result. So to actually find the result, we simply set up all of our data. We create our setup converters. We create our list of seeds. We then stream through them. We then perform the steps on each of the seeds, which is then going to return a list of, in this case, the location is what it's called in the task, but just a random number, which is the output of all the steps being performed. We then would like the minimum number, so the smallest number, when we look at compare to, so when we're comparing them, so we're kind of like ordering the list and taking the smallest number. And then because this min is going to be returning an optional, meaning it can't it will return like an empty optional if there's no data. With it, in this case, just return -1 if there's no data. But in this specific area, we have a specific input, so we know there's going to be data every time. So it's not really necessary, but just an extra check, which would showcase there's an issue if we just return -1. And I hope that kind of explained today's exercise. And as you see, it runs, it works. This is my correct result. But it's definitely a bit different from some of the other ones. It requires a bit more setup. I'm using this step converter, this entire like object setup to then create some kind of data application structure, then do some things with data, and then we do it multiple times. And then it gets kind of interesting in part 2, because part 2 is actually more or less the exact same exercise, but we then need to do it. In my case, I think it's about 2 billion data points, where when the first task only did it for like 4 or 5. So we're actually doing it for we're doing the exact same task, but we just have a lot of more data. Where before each of these data points were its own seed, now this is like the starting position, and then we need to say all these numbers from the starting position. So here we first look at 32 million seeds. Then from this starting position, look at these. So we're looking at another 4 million seeds. Then we're looking at another 105 million seeds, if I can. No, it's even more. It's actually 1 billion seeds. Yeah, so a lot of seeds. So the exercise is more either create some kind of optimized way of actually doing all these comparisons to find a result, or I just did this somewhat lazy way of simply just brute forcing, just going through all of them. But we then have some problems where, first of all, Java is going to run out of memory because it cannot handle so much data at once. So I'm adding like a jumping factor where we're only looking at 10 million data points at a time. And then we get the starting position. Then we take the next 10 million points, next 10 million, the next 10 million, next 10 million, until we hit this plus this, which is like the max area we're going to be searching for this input. So we have like a head, a tail, a current head, a current tail, where I slowly increment my current head and current tail to kind of look at the data 10 million at a time. And then for each 10 million, I find the best result and add them to a list. And then at the end, I'm going to have like, I don't know, 100, 200 best results. So then I just find the best result of the best result and print it constant in this case to find my actual result. And this takes me about 10 minutes. So it's not very optimized, and it's a very, very brute forcey way of doing it. And we're looking at some of the subreddits and other people's solution. Either you could optimize the way of doing it, or there's another way which I think is kind of funny, that instead of actually doing all the inputs, we just kind of do it the other way around. So we start at seed 0, and then we check, because we need to find the smallest possible seed. Seed 0, does seed 0 match any of our inputs, more or less, if we go backwards? And I guess in my case, I don't know if it's going to be much faster. It probably is, but it's a bit, I think, it's definitely a very creative solution, where you kind of like redo the task, and then instead of actually finding a result, you then look for a specific result. But that is very much the bread and butter of day 5, and I hope you found my solution kind of interesting. And as always, there will be a link in the description to the GitHub repository where you're going to have a look at the code yourself, because today there's a bit extra code with this entire extra Java class. But if you enjoyed this quick showcase, please leave a like and subscribe, and I wish you all a wonderful